In this video tutorial, you will learn how to set up estimation function of the mechanical and switching life of switching devices in the ED2 series IED. Before starting to work with the configuration, it is recommended that you watch the video tutorial on configuring ED2 series IEDs opening and saving of configuration file. After successful opening of the configuration file, go to the switching devices section. This section presents switching devices and parameters of their presentation in the IED. To learn how to configure them, see a separate video tutorial Logical Nodes of IEC 61850 for switching devices. Also in the switching devices section, the removal and addition of the switching devices is available for editing. Free bay controller int. Estimating function of the mechanical and switching life can be set for each switching devices. If mechanical is selected, the life will be estimated by the number of closing and tripping operations, that is, the life of the switching device's drive will be estimated. When switching is selected, both the mechanical and switching life will be estimated, which takes into account the current flowing through the circuit breaker at the moment of switching, that is, the life of the arc chute of the high voltage circuit breaker will be estimated. If none is selected, switching life will not be estimated. If necessary, it is possible to change the type of life estimation for switching devices by selecting an appropriate option in the drop-down list. For example, let's consider parameters of the switching life, since setting of the mechanical life is similar except for the parameters related to the switching life. Open the Remaining Life tab. The current parameter specifies a three-phase system of currents, the measurements of which are used in the estimation of switching life. You can change this parameter by selecting the desired value from the drop-down list. In the following tables of trippings and closings by points, the characteristic of switching life of the circuit breaker is set, that is, the dependence of the number of trippings and closings on the value of the switched current. The data for setting the characteristic are taken from the passport or operation manual for the high voltage circuit breaker. In case of estimating only the mechanical life, it is required to configure 1 point each for closing and tripping, while the current is indicated as equal to 0. It is also possible to add and remove estimation points for the service life of the switching device using special buttons. Corresponding signals are available for these points in the circuit breaker life logic buffer, displaying in the name the serial number of the point, starting from 0, the current value, as well as the number of switchings. When the specified number of switchings is reached, the values of these signals will change by a logical 1. This will mean that the circuit breaker at a given current will no longer be able to perform a switching. It is also possible to set the initial number of switchings for each phase, for example, if the circuit breaker has already been in operation. To do this, all the switching currents recorded during operation must be written down one by one in the corresponding cells. In this case, the currents must first be reduced to the minimum point from the previously specified characteristic of the switching life. For example, let's take a fixed switching current phases A equal to 7 kA. Because the life estimation function is performed by the piecewise linear approximation method, we use the equation of a straight line over 2 points and find the number of trippings at a current of 7 kA. Then, the permissible number of trippings at the minimum current is divided by the found number of trippings at a current of 7 kA and rounded up. The calculated value is recorded for corresponding phases. If there were several switchings, then calculations need to be made for each case, and the results obtained should be summed up and the value recorded in the appropriate cell. The above actions are necessary for a more accurate setting of the expired switching lifespan. The start of the mechanical and switching life estimation function is possible according to one of two conditions, either by a control signal or by a change of position. Under the by control signal condition, the life estimation function works by tripping and closing commands, which can be selected from the drop-down lists for each phase. When you select the condition by change of position, the life estimation function works by position signals that are specified in the Parameters tab. It is recommended to use the condition by change of position, and the condition by control signal only if the circuit breaker position signals are not connected to the IED. In the levels of operation area, stages of the remaining life of the switching devices are set in %. When one of the stages is reached, a corresponding signal will be generated into the logic. In the current value's registration time relative to start signal's area, the time is set in milliseconds for reliable registration of current values at the moment of switching, from 0 to 500 milliseconds, with a step of 1 millisecond. For example, in the case of start by change of position, the time is set from the moment main contacts of the circuit breaker are switched until the moment the position signal changes in the IED. And in the case of by control signals, the time is set from the generation of the closing or tripping command switching of main contacts. The set values in both cases must be offset from the times described above with some margin. In general, it is recommended to take a margin of 5 milliseconds. For example, in the case of by change of position, the value of the parameter will be the sum of the time between switching of main contacts and auxiliary contacts of the circuit breaker, the operate time of the IED's binary input, default 15 milliseconds, and a margin of 5 milliseconds. When editing is complete, you need to save it using File menu, or by clicking on the Save button on the toolbar. This video tutorial is over. We hope it was useful to you. Thank you for attention.